Welcome to Mackey's Study Circle channel. In this video, we shall see the simulations of the milling operations using, this is the part diagram. So you can just see part. So this is the part, so which is having a thickness of 75 mm and having a length of 200 and a width of 150 mm. And the depth of each hole is 30 mm, excluding the V portion of the hole. So now we will just see what all operations can be done. So first we need to create a rectangle of 200 cross 100, and then we have to have a pitch circle diameter of 100 mm, and there are totally 12 holes of 10 mm diameter each, and I can just take this as the center of both the pitch circle diameter as well as the rectangle, which is 0, 0. So with this details, let us see how to simulate the operations of face milling and also the drilling using the CADEM's caps mill software. So now we will see how to perform this using the caps mill software. So now click on the caps mill. So once the software is opened, you can just select new from the file option and select the material name, that is cast iron of medium hardness, the gray cast iron. Enter the part load and the unload time as 10 seconds. And now coming to the table setup, select the first table setup because we are going to have one single part for the milling operation. Enter the part name as mill01 and the programmer name can be the username. So after entering these details, click OK. So now we need to create the blank on the part. So going for draw options, select shapes. So since you can see that the part is nothing but a rectangular in shape, so I'll be selecting the rectangle option with center, length and width. So let me enter the length as 200, the breadth as 100 mm. So since there is no corner radius, I'll keep it 0. I'll enter the coordinates for the rectangle to be 0, 0, which is the center of the rectangle. So now you can see that the rectangle is fixed at 0, 0. So I can just fix this using the zoom all option. So now I need to create the holes inside the rectangle to carry out the drilling operations. So I require the pitch circle diameter. So for that I'll go for point pattern, select points on circle and enter the pitch circle diameter as 100 mm as given in the question. The number of holes is 12. So the angle of the holes can be kept 0 or you can give it as 30 degrees. So both will not make a difference because all the holes are aligned along the circumference of the circle of pitch circle diameter 100 mm. So enter the center of the pitch circle as 0, 0. So now you can see that the holes has been arranged on the rectangular blank as shown. So now we need to define the blank. So I'll select define the blank from draw option and enter the blank thickness as 80 mm because I'll be removing a material of 5 mm thickness by the face milling operation. So let me enter the excess material as 80 mm thickness and the Z coordinate at the bottom as -75, which is the actual thickness of the blank as given in the part diagram. So -75 indicates that the tool will come in interaction with the 5 mm of the material of the workpiece. That is why I'm entering it as -75 because the tool is going to come and interact with the 5 mm thickness of the workpiece on the workpiece. So that is why -75. And now I'll click on select counter to enter the minimum thickness. So I'll select the outer rectangle. So once it is selected, the minimum thickness will be mentioned. So now click OK. So the X, Y maximum, the blank thickness, the Z coordinate at the bottom and the minimum values have been entered now. So with all these details, the counter has been defined and the blank has been defined. So click OK. So now this completes the creation of the geometry. That is, we have defined the rectangular blank and we have also defined the holes that has to be drilled along the circumference of the pitch circle diameter of 100 mm. So this completes the geometry creation. So now we'll go to the machining window. In the machining window, we have to define the control system of the machine, which is Fanuc. So click on the machine option, select Fanuc as the control system and click on select and close the dialog box. So now let me define the machining operations. So first operation is milling, that is the face mill. So select milling and select face mill tool to carry out the face milling operation. Define by selecting new tool, and then I'll be selecting the face mill of 45 degrees, and the diameter of the face mill tool is 100 mm. So click OK. So the first tool to carry out the first operation, that is face milling, is defined now. So if you want to edit the tool geometry, the edit tool geometry can be selected. The tool material can also be selected. So click OK. Now I have to define the drilling operation. So before that, let me select the face mill tool and then select the blank. And then let me define the operations, that is both roughing and the finishing operations has to be carried out. So I'll select both roughing and finishing. And the thickness of the material that has to be removed is 5 mm as per the data, because 80 mm is what is we have defined and the actual thickness of the blank is 75 mm. So 5 mm thickness of material has to be removed. So we are going to enter 5 here, and then the surface method will be followed. We have not defined any contour, so surface will be selected. And in the cutting parameters, enter the depth of cut as 2.5 mm, because the material that has to be removed is 5 mm. So you can give a depth of 2.5. So click OK after you have entered depth of cut. You do not have to enter the return to Z values and all that. So click OK. So now it is asking from which direction the face milling operation has to be executed. So select any one circle to mark the direction of the beginning of the face milling operation. So now we have to define the drilling operation. So again in the operations, I'll select hole. Under hole, let me select drill. So selecting the drilling operations under hole, and select the drill bit by clicking on new tool. So let me select the drill operations, and under that let me select the twist drill of diameter 10 mm, because each hole is of diameter 10 mm as per the part diagram. So click OK. The material can be HSS, that is the material of the drill bit. So now select all the holes on the geometry, and any holes has to be emitted. No. Click on no. I have to drill all the holes that is there in the geometry, and then enter the hole depth as 30 mm. So this 30 mm is the hole depth excluding the V portion of the hole. So that is 30 mm, and you do not have to enter any other parameters apart from the hole depth. So click OK. So we have defined both the face milling and the drilling operations. Now let us simulate this operations by clicking on the toolpath window and clicking on the play button. So this is the simulation of the operations. So we can just reduce the speed of the simulation to understand the step-by-step process. So this is the face milling. So you can see that both roughing and finishing operations are executed in the step. And then the right hand side of the window is detailing us about the parameters like the cutting speed, the X and Y coordinates in which the tool is going to move over the surface of the workpiece. So this is the simulation of the drilling operation. So the first hole is being drilled. So it is going to follow the circumference of the pitch circle diameter of 100 mm and execute the drilling operations of all the 12 holes of 10 mm diameter. So this completes the simulation of both the operations in the sequence, face milling first and next is the drilling operation. So now I can generate the spindle power graph by clicking on documents and clicking on the spindle power graph. So this is the power availability for the given machine. And this is the power consumed details for the given set of operations. So click close. And I can also generate the cycle time sheet by clicking on the cycle time sheet, which is going to detail me about the operations and the corresponding tools for the operations, and the quantitative data like the tool speed, the cutting speed, and the feed, depth of cut and all this. And the total cycle time can also be seen. So it is around 13 minutes, 10 seconds. So let me save this cycle time sheet in the PDF format in an appropriate folder. Let me give the file name as mill01, click save. So it has been saved in the PDF format. I can also generate the CNC program for this particular simulation by clicking on NC program. So now the program is saved. Let me enter the program name as mill01 and the program number as 0001 and click OK. So click on edit to view the NC program generated. So now this is the NC program which is generated. So you can see that the NC program is generated automatically with the appropriate G codes and the M codes and also the dimensions of the workpiece. So both the operations, that is face mill and drilling, will be mentioned here in the CNC program. So let me save this CNC program in the same folder. So this is how we can extract the relevant data from the simulations of the milling operations using the CAPS mill. So this is how the CNC program is generated. So you can see that both face mill and the drilling operations have been recorded in the NC program. So this completes the simulation. You can click exit. So you can save the file. So the extension in which it will be saved is .cpm. Click save. So this completes the first exercise. Thank you all for watching.